Hi, welcome to this video on Project 2 titled Deques and Randomized Queues. In this video, I'm going to walk you through the problems in the project and give you some hints on how to go about solving those problems. The goal of this project is to implement some basic data structures using arrays and linked lists as the underlying data structures. And we want to make sure that our implementations are generic and also iterable. The zip file for the project, which can be downloaded from this site, contains the project specification as a PDF, the starter files for the problems in the project, a test script, and also a template for writing your report for the project. Now this video is going to be of help only if you have read the write-up for the project and have understood the problems involved. So please make sure that you read the project write-up before you continue with this video. The first problem is called Deque. Now Deque stands for a double-ended queue. All right. So here in this problem, we want to implement an iterable data type called linked Deque that uses a linked list as the underlying representation. All right, and this data type linked Deque needs to support this API. So let's go through the API. So there is the constructor that lets you construct an empty Deque. And then once you have an empty Deque, you can check if it's empty or not using this function method is empty. And then you can ask for the number of elements in it by using this method size. And then you can add an item, a generic item, to the front of the Deque using this method add first. You can add a generic item to the end of the Deque using this method add last. And then you can remove an item from the front of the Deque using this remove first method that simply removes it from the front of the Deque and returns it to the caller. Similarly, you can remove an item from the end of the Deque using this method remove last, and then you can get an iterator using this method iterator, and that will let you iterate over the items in the Deque from front to back. And then there is this toString method that returns a string representation of the Deque. So that's the API. And here are some hints on how you may want to go about implementing this API. So for the underlying data structure, we are going to use what is called a doubly linked list. All right. And this linked list is going to be represented by a data type called node. Right? And each node in this linked list is going to store a generic item, and it's going to have two pointers, one called next pointing to the next node in the linked list, and a pointer called previous which points to the previous node in the linked list. Okay, so now notice that the first node here has no previous, but it has a next, so the previous is set to null. And then the last node has no next, so that is null, but it surely has a previous, which is the second last node in the linked list. So that's how a doubly linked list looks like, right? And it's a structure like this that you want to use to implement a Deque, a double-ended queue, right? And we are going to maintain two pointers, first pointing to the first node and last pointing to the last node of the linked list. So what do you need for instance variables to implement the linked Deque API? Well, you need an integer n to store the size of the Deque. So n is going to represent the number of elements in the Deque or the number of elements in the underlying linked list, number of nodes in the underlying linked list. And then you're going to have a pointer to the head of the Deque called first, and that is of type node. And then you have a pointer to the tail of the Deque, and that's called last, and that's also an object of type node. Okay, so those are the instance variables. Now let's talk about how you implement the methods in the API. So the first thing that you want to do is implement the constructor. So that's the constructor, and here you just want to initialize all the instance variables to appropriate values. All right, and then in isEmpty you need to test whether the deck is empty or not, and that can be done in several ways. Uh, and you simply check if the underlying linked list is empty or not. Okay, and you return true if it is empty and false otherwise. The size of the deck is fairly easy to implement. It's basically stored in this instance variable in, and then in this method add first, what you need to do is add this generic item to the front of the deck. All right, so that involves adding the given item at the head end of the deck, meaning the front of the deck, and incrementing n by 1. Okay, now here you have to be a bit careful about some edge cases. Okay, now when this is the very first item that you're adding to the front of the deck, you need to make sure that after that item is added, when you have just one node in the underlying linked list, you need to make sure that both first and last point to that node. All right, so so that's an edge case that you have to handle. Right, if it is not the first node, then you may have something like this. You have a linked list, let's say with 2 elements, and let's say you're making a call to add first to add an item to the front of this linked list. So there are pointers here, and then you're adding something here. In this case, you want to make sure that this is now the new first, and this is pointed to by last. And then you want to make sure that the next of the new first is pointing to the old first, and the previous of the old first is pointing to the new first. Okay, so that's how you work on add first. Add last, it's a similar idea. So here you're adding something, the generic item, into a node at the end of the deck. So here again, you have to be careful about the edge case scenario. So you first add the given item at the tail end of the deck, and then increment n by 1. And now if this is the very first item that you're adding to the underlying linked list, you want to make sure that you end up with a node that is pointed to by both first and last. But if it is not the first node, then you already have a linked list, let's say with 2 elements, this pointing to that pointing to that, and this is given by first, and this is pointed to by last. And now what you want to do is make a new node that last points to, and then you have to make sure that the previous of the new last is pointing to the old last, and the next of the old last is pointing to the new last. Right, so you have to set this up. Okay, so that's add last. What about remove first? So here you need to remove and return the item at the head end of the deck and decrement n by 1. All right, so if you have a linked list, that's that, so this pointing to that, and that pointing to that, this pointing to that, that pointing to that. So let's say this is the linked list, and you want to remove and return the item that is in this node, and first is pointing to this guy here. Right, so all that you need to do here is make first point to the next item of the current first. Right, Okay, and then you also need to make sure that the previous of this guy is set to null. Okay, and here again there is an edge case to worry about. What if this call to remove first is on a linked list that just has one node? Well, in that case you're going to go from a one node list to nothing, right? So you have something like this, both first pointing to that and last pointing to that. And when you make a call to remove first, you need to end up with a scenario where first and last point to null. Okay, so that's an edge case that you need to take care of. What about remove last? It's exactly the same idea. You remove and return the item at the tail end of the queue, and you decrement n by 1. So here you have a linked list with pointers as such, and you want to make sure that the new last is now this guy here, the node that is the previous node of the current last. Okay, and you need to make sure that the next of this guy now is pointing to null, which amounts to removing this guy. Right? And here again you need to worry about the edge case where you have just one node in the linked list which is pointed to by first and last. And when that's the case, you need to go to a state where both first and last point to null. Right? So that's an edge case that you need to worry about. Okay, what about iterator? Well, that's straightforward. You simply return an object of type Deques. All right, and how do we implement Deques? Well, that's going to need an instance variable which is a pointer to the current node, right, in the underlying linked list, and it's going to be a pointer to the first node in the deck, right, on the head end of the deck. And we're going to call this a pointer current, and it's simply of type node. In the constructor, what you need to do is initialize that instance variable suitably. And then how do you implement has next? Well, you simply check if the iterator has more items to iterate or not, which means you simply have to check current against last. All right, or you can check current against null. Okay, and then what about next? Well, here you need to advance the current pointer by 1. Right, so you simply grab the item that is in current and into some variable, and you advance current to the next node and simply return the value of that variable. Right, so that's how you implement next. Okay, so now let's move on to the next problem, which is a random queue. So here what we want to do is implement a generic iterable data type called resizing array random queue that uses a resizing array as the underlying representation to implement the API that is shown on this slide. All right, so the resizing array random queue data type is going to have this API. It has a constructor that builds an empty queue. It has the method isEmpty to test whether or not the queue is empty. It has a size method that returns the number of elements in the queue. There is the enqueue method that takes a generic item and adds it to the queue. And then there is the Deques method that simply returns an item from the queue, but notice that it removes and returns a random item from the queue. All right, and hence this data type is called a random queue. Okay, so enqueue adds the item to the end of the queue, whereas Deques removes and returns a random item from the queue. Okay, and then sample is a method that returns a random item from the queue but does not remove it. Okay, and then iterator gets you an independent iterator over the items in the queue in random order. All right. Um, so each time you iterate over the random queue, you're iterating over it in a random order. Right? And then finally, there is the toString method that returns a string representation of the queue. Okay, so how do we implement this data type? Well, we're going to use a resizing array as the underlying data structure. And then for instance variables, what we're going to need is an array of generics called queue. And this array is going to be a resizing array, right? And that's the array that's going to store the items of the queue. And then we will also need an integer n to keep track of the number of elements in the queue. In the constructor, what we're going to do is initialize those instance variables appropriately. Right? And here we want to create that array queue with an initial capacity of 2. Right? And then we will resize it as necessary. All right. In isEmpty, we need to test whether the queue is empty or not. All right? And that can be simply done by checking the value of n and comparing that to 0. Okay? Size returns the size of the queue. That is extremely straightforward. Just need to make use of n, the instance variable. And then in enqueue, what we need to do is we take this generic item and we need to insert it into the queue at the location given by the value of n. So let's go through the steps. So the first thing that you need to do is check if there is room for this new item. So if the underlying array, if Q is at full capacity, we need to resize it to twice its current capacity. All right. And then we need to insert the given item at the index n in the array Q. So the given item goes at the index n. And then we increment n by 1. Right? So that's the enqueue operation. What about dequeue? So remember that dequeue is supposed to remove and return a random item from the queue. So how can we do this? Here are the steps. So take the item at qr, okay, and save it in some variable, right? Let's call the variable item. So take the item q at r and save it in item. What is this r? Well, r is a random integer that is from the interval 0 through n, right? Where 0 is inclusive, n is not. So get a random integer r from that interval, and then the item at r in q is saved in this variable item. And then simply set qr to be q at n minus 1. All right. So you may want to think about it as such. So you have q and its elements. So 0, 1, and so on, some random element r, and all the way up to n minus 1, right? So what you do is you save this value into some variable item, and then you set qr to be q at n minus 1. So you just copy this guy into this slot, okay? And then you set this guy here to null, okay? This is to prevent loitering, right? You set q at n minus 1 to null, and then what you do is you check if q is at quarter capacity, and if so, you resize it to half of its current capacity. So you shrink the array, right? And then you decrement n by 1 because you're dequeuing an item, and then finally you return the value of this variable, right? This guy here. So those are the steps. Okay, what about sample? Well, sample is extremely straightforward. You simply return q at r, where r is a random integer from the interval 0 through n minus 1. Right? And notice that sample simply returns an item, it doesn't remove it from the queue. What about the iterator method? Well, that's easy. Simply return an object of type random queue iterator. How do we implement random queue iterator? Well, here are the instance variables. You need to have an array to store the items of the underlying queue. Let's call this array items. It's an array of generic items. Okay, and items is going to have the same size as n, which is the number of items that you have in the queue. Okay, so items is going to be of size n, right? Okay, and then in addition, we also need an integer called current to keep track of the current item that we are looking at. All right. Okay, in the constructor of random queue iterator, what do? We first create this underlying array items with capacity n, the number of elements in queue. And then we simply copy the n items from queue into items. Simply copy them into items, right? And then shuffle items, because this is a random iterator. So take this array items and shuffle it. So here again, use a suitable method from std_random to implement shuffle. So just use a method from here. Don't write the shuffle algorithm yourself. All right. And then finally, initialize current appropriately. Okay. How do we implement has next in the iterator? Well, you simply check if the iterator has more items or not. So you compare current with the value of n. All right. How do you implement next? Well, return the item in the array items at the index given by current and simply advance current by 1, increment current by 1. All right. So that's how you implement next. Okay, so the last problem is called subset, and here you're required to write a client program called subset.java that takes a command line argument, k, as an integer, and then it reads in a sequence of strings from standard input, right, using stdin.readString method. And then what it does for output is it prints out exactly k of those strings picked uniformly at random. Okay. Now each item from the sequence can be printed out at most once, and then you can assume that k is greater than or equal to 0 and less than or equal to n, right? Where n is the number of strings that are read from standard input. Okay, so how do we implement this program? So here is how you do it. You first create an object of type resizing array random queue, which is what we implemented in problem 2. Let's call this object q, and then what you do is you read strings from standard input and simply throw them into the queue. Right? So for each string that you read from standard input using the readString method, just insert it into the queue. Right? And then what you do is you deque and print k items from the queue. Right? And k is the command line argument that you receive in the program. Right? So simply deque and print k items from the queue. Right? So that's a very simple client program. Now, to receive full credit for each problem, make sure that your solution implements all the corner cases and performance requirements for that problem. All right, so be careful with this. So if there are corner cases listed for a problem, you need to implement those, and if there are performance requirements stated for a problem, you need to meet those requirements in order to receive full credit. For your report, make sure you use the given template, report.txt, and make sure that you mention the time that it took in hours for you to complete the project. Provide a short description of how you approached each problem, about any issues that you ran into and how you resolved those issues. Acknowledge any help that you received, and then also provide other comments such as what you got out of this project and whether or not you liked working on it and so on. Now, before you turn in your files, make sure that your programs meet the input and output specification, which you can do by running this command, and also make sure that your programs meet the style requirements, which you can do by running this command here. Right? And then finally, make sure that your report is not too long. make sure that the lines don't run over 80 characters, and then also make sure that your report is free of spelling and grammatical mistakes. All right, so that concludes this video on project 2. Thanks for watching.